Good evening, everyone. Sorry for the delay. Hello. Hello,
Good
sir.
evening. Hello,
Good
welcome.
evening, sir. Good evening, sir.
Sorry for the delay. Actually. Okay. So, what's today? What we have to discuss today? Let me know. So today's session is open session, right?
Right,
Regarding
sir.
week 4. Yeah.
Right, week 4, sir.
So
Summarize week.
summarization of week 4. Huh? I also forgot, man. What is there in week 4? So nothing. It's not like that.
Last time you told this is the easiest week actually, so
Week 4 compared to since week 1 and 2, I think there are multiple continuous, sorry, not continuous, discrete random variables, right? And week 3 is, I think it's regarding expectation variance, which you have already studied in stats 1. It's just to like extension to the multiple random variables, right? So how was
So
that
we have some doubts, sir, in activity questions.
in week 4?
Yeah, week 4, activity 4.4, 2-3 questions doubt.
Yeah, we'll see. So we'll see one by one. Okay. All of you have studied week 4, huh?
Yes, sir.
Yes, sir.
Yes, sir. So especially support, can you just repeat that because I have a doubt regarding the
Okay.
concept.
Support, huh? So
Yes.
okay. Support is nothing but where on which area that in that area you are going to integrate the joint PDF, actually joint function. So you will see the how to deal with that. Okay. Which questions? Activity question 4.
So activity 4.4, question number 2, 7, and 8.
Okay.
So 2, I have a little doubt, like it is saying that first, last 2, they are not CDF. Last 2 is not CDF, it's because they are decreasing. But why the second will be CDF, sir? Because it should be a mixture.
But CDF can be a mixture, right? So
Yeah, the first one is also a mixture. So why first is considered to be not a CDF and second is considered to be a CDF here?
okay, we'll see. I don't know what is the answer. We'll see. So you tried that one?
Yeah, I tried that one, and 7th I couldn't do. 8th I have little doubt. 8th I could do, but doubt is there.
Okay, so question is, which of the following functions cannot represent the CDF of a continuous random variable? And answer is first, 2, and 3. So you
Yeah.
are saying this first is not a CDF, right?
Yeah, first is not a CDF. Last
Sir.
2 is not a CDF because
Sir,
they are
how-
decreasing.
Sir, how to approach this kind of problem? Can we start from there? Like, how to?
Yeah, we'll see.
Yes.
So I will try to draw all the functions, okay, these functions, and you only can answer why it can be a CDF or why so all 3 are not CDF, right? A,
No,
B,
only the second one is a CDF.
not second one, right? Okay, only second one is CDF. Okay.
Yeah,
First,
last 2 is not CDF because it's decreasing.
okay.
But first one and second one, then first one should also be a CDF.
Okay, let's see. We'll try to draw it, okay? So this one is slightly easier, right? This week 4.
Nothing is easier, sir.
Nothing is easier.
True, true.
So
Compared to
comparatively,
other
it is better than other weeks.
Because I think and it's if you understand, I think discrete random variables, same things are here, right?
Couple of concepts are there, sir, which are getting mixed.
Okay.
Sir, we are understanding the concept, but when it comes to problem solving, then we are getting not getting the approach how to, like how to
How to
tackle
start
that
the thing.
problem.
Yes, that's what means concepts are not clear.
Concept wise, it's okay, but
Yeah. Okay.
problem
Sometimes-
Application wise, it becomes problem actually.
Yeah.
Hmm.
Sir, I think sir should include some more problems like what is given in the activity questions and in the graded assignment. That would help us like how to instead of directly going to the graded assignment and tutorial. Okay, we are getting the tutorial because it's solved, but practice assignment and graded assignment, it's somewhat like it doesn't match with the tutorial and the activity questions.
Tutorial questions, I think they are like comparable, right? With comparable.
Yeah, that is even solutions are there, but practice assignment and the graded assignment.
Activity questions are very simple one. That is true, right? Because those are like those are the questions under that particular lecture. Practice assignment questions are all the questions over whatever is there in that week, right? Okay, maybe it's slightly there is a variation in the difficulty level between practice and graded, but I think tutorial questions are there. Mostly all the varieties it is covered there. But let's see.
Yes, sir. Let us see this one, sir. Yes.
Yeah. So can you tell me so how I can draw this first CDF? So f of x
So
is there, right?
first
So
one is
my
minus
x,
2 is 0.
yeah, this is my
Less
x.
than
This
minus
is f
2
of
is
x.
0.
Okay. So less than minus 2 is 0. So let's say suppose minus 2 is here somewhere. So
Yeah.
that means it is starting with minus 2, right?
Yeah.
Then between minus 2 and plus 1, it is 1 by 3, 0.5x plus 1.4. So
0.466.
so it will be like this. How can I write this? How can I draw this? So first of all, it will start. So this is a straight line, right? You can understand this is a straight line, and with I can say
We can put the values of -2 and 1.
yeah, we can do that also, but we don't know, right? This is a discrete or continuous, right?
Sir, is this like x will be taking value here from
Between
-2, -1 and 0? I mean, if we substitute the value
can
of
be anything, right?
x,
Between here, what is written there?
yeah, -2, -1 and 0.
It is not a discrete random variable, right? It's continuous.
Okay.
How can you say that this is a it is only taking -2 -1 and sorry -2 -1 0 and 1? No, right?
Okay.
So
So
this
x can be anything between that range.
But sir, it is given in the interval -2 to 1.
so in between that any value it can take, right?
Okay.
Right.
Any real number it can take.
Yeah, because x
It
is
can
there,
take an
so it
okay,
can take
okay.
anything, right? It's correct, right?
Okay.
So this can be a line with slope 0.5 by 3, and so it should start with 1.4 by 3. So
Yeah.
what's
0.466 it will come.
okay? So it will start with some here, right? Somewhere here, correct? And it's having some slope. So this is positive slope. So that means it is going until 1. So it should go somewhere like this, correct? Is this correct? Okay.
Positive because mx is means m
This
is
is slope,
positive
right?
slope.
Mx plus c. So c is here. So you can see that if you put the value of minus 2 here, what it will happen? 0.5 by 3 into -2 plus 1.4 by 3. Can you calculate this one?
Yeah, I calculated, so I'll tell you.
What's the value?
Yeah, I'll
-1
tell you. It comes 0.133. 133.
0.133. Okay. And okay, so this will intercept somewhere here. So let's say this value is what? 0.133. So you can say that this is the sudden jump here, right? So this is some discrete. So at -2, its sudden jump is there, correct?
Okay.
And you can have a straight line until 1, something like that. Then it is constant between 1 to 2, correct? Okay. So at 1, what is the value of what can be a value of this function?
1 or -1, sir?
Now 1, right? Between -2 to +1, right? So at 1,
Sir,
One is
sir,
not
it should be
included.
sir,
0.7,
it should be
0.7, sir.
it should be less than
0.7.
1, no, sir.
huh?
It should-
0.633.
at x equal to
One
x,
is not
0.7.
included.
0.7,
No, but
sir.
1 is not included.
It should
But
be
it
less
is
than
that-
1.
Yeah, correct,
But
correct. But tell me what can be the value? If,
0.7, sir.
no, that 0.7 is different one.
Say,
Oh,
we,
0.63. It's a 0.63.
Huh?
It's a 0.63.
0.63.
sir,
Correct.
we can take a 0.95 like that value we can take, or 99.99.
Yeah, okay. Try it like that. Okay, that is fine. What I'm saying is around one, what value it can take. So it's like that if this is a continuous interval, right? So it can be 0.999 something is there, right? Instead of that, what I'm saying is if I put 1, what value it can have?
0.7.
Here it's a 0.63. I'm calculating it.
0.63 or 0.7?
Yes, sir.
It will be 0.7 because
Because it's
0.5
continuous,
into
right?
1 is 0.5 plus 1.4 is 1.9 divided by 3. That way, no?
0.63.
So, and I mean, the condition is also given 1 is less than or equal to x less than 2 is 0.7.
So
0.63.
here in this range, what it should look like this, right? Correct. Okay, leave this.
No, sir, there is a
No, it
sudden
won't
jump
look like
from
that.
0.63 to 0.7.
That's what I'm trying to say. So here it should be having some jump, right? When you put
Yes,
this
sir. It's a
value,
jump.
and then it should be have at 0.7, it should be having something like this, correct?
The
Constant
jump
value.
0.7 is already there, sir. Like 1 to less than 2, there is a jump 0.7.
Where this is not a jump between 1 and 2, it's a constant value, right? 0.7.
No,
Yeah.
from
This is
It's
horizontal.
talking about
0.63
from
to
second interval
0.7.
to third one.
Yeah, from the second interval, like from 1 to 2, there is a jump.
Not from 1 to 2,
No.
from less than 1 to 1.
Yeah, less than 1 to 1, right? So
Less than 1 to 1.
here I'm showing this, right? Here, right? This red line, correct, na? Or no? And then
Yeah.
what we'll have? Then we have this 0.3 x plus 0.1 between 2 to 3. So here also one line is there, and then we have some constant slope, right?
Yeah.
See,
So this is a mixture, sir.
so this is a mixture of, so this is discrete, continuous. What are the properties of CDF?
Sir, this last line is not clear, sir. Like there is a jump from 1 to when it is less than 1, and then when it is equal to 1, so there is a jump, right?
Okay, tell me, here this 2 is there, right? Here 2 is there.
Yeah, and then when it is less than 2 and when it is equal to 2, then there is no jump. So how to predict that?
Yeah, that's what I'm trying to say. So here 2 is there, correct?
Yes,
This
yes.
2. What is the value here?
0.7.
0.7.
Add this 2. If you
Yes.
replace that x with 2, what is the value?
Yeah, 0.7.
So add this 2, right?
Yeah.
Left hand side and right hand side both are having same value.
Yeah, but in that case,
But
2
here-
is not. But in that case, 2 is not included, no, sir. 2 is not included. It is less than.
No,
Less than
that's
2.
okay.
Yeah.
That's okay. In continuous random variable, right? If you recall it, this doesn't matter, right?
Yeah, this doesn't matter. Yes, sir
Because
has said
because the CDF is like because at the particular point, right?
it is
You
always
want
zero.
zero value, correct,
Correct.
right? So it should be the cumulative probability.
But then in earlier case, how we identified that
So
there is a
here,
jump?
here you see at this one, the left hand side,
Yes.
if you put it here, so it will be 0.5 plus 1.4 is 1.9 divided by 3. So what value it is not having 0.7, correct, right?
Yeah, it will come around 0.63.
Yeah,
It will
and
come
then
around,
and at this one is 0.7. So here there is a gap, right? You can see, right?
so any of you are putting
Sir,
the value and then
agreed,
only
sir.
calculating it.
Correct.
Yeah, agreed, sir. With the graph, what it is showing, sir, as per the lecture, this is a mixture.
Correct. Now, yeah, this is mixture, right? Now we'll go for the second case.
Yeah.
Now we'll try to understand
Yes, that is
everything.
needed, sir. That is needed. Yes.
And then we'll compare. What I'm saying is, so I don't know. This is visible, right? Yeah. You understand, right? Now you at least you understand how to draw that graph, right?
Yeah.
Yes.
Yeah.
Okay. Now we'll go for the second case, and then we'll compare with all the properties of CDF. You guys know the properties of CDF, right? Okay, that's it. It is another thing. So again, I will try to draw this graph. So okay, again, sorry. Here -2, it's 0, right? Below -2, it's all 0, correct? At -2, what's the value?
0.
No. In this equation, in this
Yeah,
equation.
at
It's
minus
coming 0.
At
no.
-2.
It's at
Okay,
-2.
it's 0, right? It's
Yes,
0.
it's
Yes,
zero.
it will be 0, sir. I am
0,
putting
correct,
the
correct.
values.
Yeah. Now that means until 1, this graph will start with this, right? Like this, something like this.
Correct.
Yeah. Yeah.
So, sir, again we are putting x equal to 1 and then we are finding the
Yeah.
value 0.7,
Yeah,
right?
yeah. Now if you put 1, what will be the value?
0.7.
Okay. This is 0.7, right? Now add this again, 1, we have 0.7 there. Between 1 and 2, it's
0.7.
It's
0.7.
flat. 0.7.
Okay. Then
From 2.
sorry, at 2, what's the value? Both the
0.7.
side, both the sides.
0.7.
Side, RHS is 0.7, correct?
Right.
Between 2 to 3, it's again
1.
1.
and then at 3, it is from 3 greater than 3, it's 1.
So it's a continuous.
And now you can understand, right? This
Yes,
is continuous.
it's a
There is no
continuous.
sudden jump.
Yes.
Okay.
In the
You mean to say the graph
sir,
is
in
continuous?
the second one, sir, in the second
Yeah.
one, you have substituted there as 1. In the second equation, you have taken it as 1.
where this one,
In my -2 less than equal to x is less than 1. You have put there as 1, and so you got 0.7.
both the sides. See, LHS and RHS are same. So this is the, I think in mathematics, have you studied about this thing, right?
Sir,
Differential and continuous thing. If something is continuous, then it can be a differential function, like that. Have you studied? So what does
Yes, sir.
what is continuous there? The left hand side value and the RHS, right? They both should have the same value. Then it is continuous. Correct?
Sir, I have a doubt. Sir, in case of a CDF, it should be a non-decreasing function. That means it should be upward trend. That means if you are going towards the infinity, it should be 1. And in both the cases, it is going to 1. But if we go in the left hand side minus infinity, that is also, it is satisfying that it is negative. And at the same time, the trend is in increasing both in the cases. So how we can say that one is CDF, one is not CDF?
So okay, in between these two graphs, right? So I'm writing this as 1 and this as 2. So in this 1 and 2, what is the difference? If you see,
in the
One
first
it is
one, there
breaking.
is a stepwise increase at 0.1 and -2.
yeah. So this here it's not continuous, right? At this point,
Right.
here what is happening? At one value, this one value, we have 2 probability values, correct?
Right.
So that means it is breaking there, right? That point, it's breaking.
Yes.
Right? This is actually a combination of a discrete random variable and a continuous random variable. This is a mixed function, right?
Right.
And in this case, what is happening? Whatever you are getting, right, it's continuous. There is no sudden jumps anywhere.
Right.
So that's why it is continuous. At any point in this function, in this CDF, if you can see, if you take any single point somewhere, can you get 2 different values?
No.
No, right?
No.
But here in this case, what is happening? We are getting 2
different values for
So
same
that's
number.
why it is not continuous, because in continuous function, right? So it's a similar thing actually in mathematics, whatever studied, right? The continuous function, what is the definition of it? The left hand side of it and the right hand side of it, it should have the same value at one point.
Right.
Correct? No?
Right.
So that is
same limit at one point.
Same thing is there. So now you can understand first what is the difference between first and 2.
Right.
Okay,
So you can now first one is a CDF or not. CDF of a actually both are CDF, right? Both are CDF.
Right.
But first one is a CDF of a mixed function. So means like discrete plus continuous. Right. And the second one is the CDF of a continuous random.
Okay.
So that is why this is correct.
Okay.
Understood,
sir.
Both are correct. Okay.
Right. And third and fourth, I think it's you guys only told, right?
It is decreasing.
And CDF can't be decreasing, so that's it.
Okay, sir, can you scroll down a little bit?
Where in the question?
Yeah, question below that. Okay, sir, can you just explain me regarding P of x equal to 0? Because if we put in the equation, say x is greater than equal to 0, less than 1. So in that, I am getting 0.5. But
No, probability of x at a particular point is 0. It should be there only in the
CDF,
interval.
right? In CDF, sorry, in continuous random variables, we are not, since it is continuous, right? We are not able to find the probabilities at one point.
Okay. Here in the question is mentioned.
Generally, what probabilities we can find? Probability that x is less than or equal to some value, right?
Okay.
That is the definition of CDF.
Yeah, that is the CDF. Yeah.
So at particular point, you take probability that x equals to 1 also, it should come as 0. Particular point, yeah. If it is probability that x is less than or equal to 1, right? Then you are able to find the probability. Or x is, so if question number 3 is find the value of probability that x is less than or equal to 0 or less than 0. So then what is the probability then? Actually, this one, right?
This one, right,
Yes,
sir?
yes.
So if you put 0 here, you'll get probability 1 by 2, it's 0.5.
Yeah.
Okay.
Because it's cumulative, right? Whatever you're finding is a cumulative probability. We are not able to find the probability at certain point in continuous random variable. That is always be 0.
Okay.
Sir, but will it be correct directly putting the value and calculating the
Yeah, that is correct. That is correct.
Since we can put the
Because
value
it's
of x
CDF
in the
no.
But we have to
Okay.
Yeah,
in this
before
function
it is,
itself.
Before this it is 0, so we can put
Yeah.
it.
So I will tell you how it can happen. So let's say if this is continuous random variable, right?
Right.
This is CDF of continuous random variable. If I asked you to find probability that x equals to 2, it should directly equal to 0. But if I wanted to find probability that x is less than or equal to 2, so which probability it should include actually? It should be this one.
Yes, complete up to from minus
right.
Up to area.
Yes.
So how can you find probability that x equals to 2? So this is actually 0.7, right?
Correct.
You know this is 0.7.
Yes.
But how you can find from this function? You can actually doing what you are doing here actually in this second one, right? So this at 2 it's 0.7, and here also see if you put this 2 here, 0.3 into 2, 0.6 plus 0.1, 0.7, right? You are putting that value directly, you will get that answer. So this is the definition of CDF itself, right? So it is giving you the cumulative probability itself. So it's
So it is in and around x equals to 2. In and around x equal to 2. Less than 2, greater than 2.
Sir, just a follow-up question to this kind of functions only. Say for example, we have a thumb rule that if it is capital Fs, then it's a
it's a CDF.
CDF. Otherwise, it's a PDF, right?
Yeah,
say
small f.
Apart from that, if say for example only functions are given like this, so how to identify whether it's a PDF or it's a CDF?
Mostly it will be written here, right, in the question.
Say for example, I know
if it is not written, then you can direct follow, like in this course at least, we can follow. So we are generally following this small fx of x, right? So this is in case of continuous random variable, this is PDF, okay, and capital Fx of x is CDF. So this is the general notations we are following in this course.
By going through functions, is there a trick that we should come to know that it's a PDF function, it's a CDF function? By going through functions,
you can by visualizing. See, this is the pattern of it, right?
Yes, these kinds of functions are given, right?
Yeah. So generally, PDF will be given like this. Let's say fx of x is equals to some what, x square or something like that.
No, sometimes that is also given in terms of inequality, sir. In this course itself, it is given in terms of inequality, right?
But generally it will be written there. So what is it a PDF or a CDF? Okay.
In the question, it will be mentioned if it is PDF. Or the question.
Okay. Any other question in this? Some 2, 6.
I think she said 7, 8. No, she said 7, 8.
I don't know. What's the question? Sorry. So okay, this is the same rule we are applying. We are applying the same rule in Python, right? So before asking me the question, just please tell me your name because I need to know who is talking.
6 is 0, sir. 6 is 0. That's clear.
6 is 0, sir.
Okay. 6
is 0.3.
Sorry, sir. The jump is there. Jump is
there.
Jump is there.
Yeah, jump is there. Yes, sir.
Okay.
Yeah.
7th one, sir. 7th. Sir, before that, sir, please go to the 8th one.
Now I think this 6, 7, 8 are depending on this PDF, right?
Yeah.
Yes. So you guys just tell me now. We have learned this. So 6th question you understand. It's 0.3. There is jump. Find the value of probability that 0 is less than or equal to x is less than or equal to 2.5. So
So it should be f 2.5 minus f0.
f 2.5 will be here somewhere, right?
Yeah.
Okay.
And
Sorry.
f0.
2.5 will be I think somewhere here.
Yeah.
And 0 is where? Here.
Yeah.
Okay. So how can you find this? What we have to do?
We have to find out the slope of the two lines and then find out the value of y at that particular point.
Correct. So okay, I will show you how to solve it. Just can you tell me with these values? I'll try to draw it. Sorry. Okay. Sorry. Okay, tell me the values from where it is starting. Is it starting from 0 or 0, right? Starting from
-2 to no. Yes, 0 to minus.
I think it's -4 maybe.
Yeah, it should be -1.
Let's see. Okay, maybe I'll start from here itself. So -2, 0, 2 and 4. Okay, with -4 its values what? It's 0. Okay. So can I draw 0 here or should I draw 0 here?
Go
Yes,
above.
Okay. Okay, fine. That's I'll start with 0 here. Okay. At this point, what's the value here?
The 0.3.
Yes, there is a jump. Yes.
0.3. Okay. Then this line goes until 2, right?
Yes, sir.
So okay. What's the value here?
0.5.
0.5. Then from here to 4. It's going 4. Sorry, 3 is there, right? 3 it's going until 1 and then it's okay. So here it's 3 and right 3 here. This is something steep slope, right? Sorry. It's starting from 2, right?
Yes.
Maybe some. Okay, this is 1, right?
Yes.
Okay. Now we have to find the value at 2.5. So 2.5 will be somewhere here.
Yes.
Yeah.
Somewhere here, right? This point. And we have to find the value between 0. So what should be the probability? So okay, sorry, here it's 2.5. So it should be this area, right?
Yes.
Okay. Now you know this is what I'm saying is this area, right? Okay, I think it's 0 is here, so maybe area should be between here. Okay, this kind of area, right? It's properly visible, right? You understand, right? There is maybe okay, now it's becoming bad. Okay, so here let's say this value is somewhere here, it's 3, here this is 2.5, and suppose here, right?
That's 2.
It's 2.
2.
Now it's understandable, right?
Yes, sir.
Yeah.
Okay. Okay. Now I wanted to find this red area in this region, right? So how can I find the area? So you know there is a method of by using the triangles and square, right? So how can we do? So here I am able to find one triangle, right? This triangle plus this triangle plus, let's say what else it can become?
Parallel
Using only 2 trapezium.
Trapezium, if let's say you don't know the area of the trapezium, suppose I don't know the area of what is the area of trapezium. So what I can do?
Then we have to do with this method.
Right.
So by simply finding out the slope also we can find out the value of y.
Yeah.
Sir, we can.
That also, that is also one of the region. Also,
so we can break into two parts, na? First line and the other line, and then solve.
Actually, see, that is the thing. But if you don't understand, then that's why I just wanted to tell that this area we have to find. So how you can find it depends on you. You can actually find the equation of a line, and you can directly put the values there, and you can find the value of probability, right? So let's say.
Sir, can you please join the lines, sir? Like which line? There is one line and there is again another line.
Okay.
Sir, we need to find both lines, no?
Yeah. So here, correct. This kind of triangle it can be. I'll try to show here. So this line, right? My cursor you are able to see, right?
Yeah.
So this is one triangle, correct? And this is one triangle. To find the slope of the line. So how to find the slope of the line? So what is the equation of a slope of line? dy by dx, right?
Change in
y,
change in x. Y1
upon x2 minus x.
So here, what is this? This line, right? This line. So y2 is 0.5 minus 0.3. It's 0.2, correct? And here,
and x is
change in x is
4.
2 minus 2. So it's 4, correct? So here
0.2 by 4.
0.05.
So here this is 0.2 and this is what? 0.4, right? So what is the slope of this line?
No, sir, 4, sir.
4.
Sorry.
It's 4, sir.
Yeah, sorry. So slope, if I'm denoting by m, so it should be what? y2 minus y1 divided by x2 minus x1. So y2 minus y1 is what? 0.2. And x2 minus x1 is 4. So this is 0.05.
0.05.
Correct? So this is the slope of this line. Okay. Now, what is the slope of this line?
1.
0.5.
0.5 divided by
0.5
by 1.
And
divided by 1.
This is
0.5.
What? 1, right?
1.
Okay. Maybe this diagram is not that clear. So here you can see this y2 minus y1. So 1 minus 0.5 is 0.5 and 3 minus 2 is 1. 0.5 divided by 1. Right? So this so slope of this line is m is equals to 0.5 divided by 1, which is 0.5. Everybody understand, right? How to find the slope?
Yes, sir.
Yes, sir.
Right? Okay.
Yes.
Okay.
What is the?
Anyone is having doubt to find the slope?
No. Okay.
No, right? If you are having a doubt, right, tell me here itself. I will again explain it, because see, if you these topics are slightly difficult to understand. So if smaller things, if you miss, right, then you will not be able to understand it. Okay. So now tell me, from where to where I need to find the area.
2.5 to 0.
So this is one line, right, between 0 to 2 with slope what?
0.05.
And this line is from 2 to 3. So we should not go to 2 to 3. It should go from 2.5. With the slope is
0.5.
So tell me how to find the probability now.
Write down the equation and integration with the given limits.
So what is the equation? How to find the equation of the line?
Equation is y is equal to mx plus c.
Yeah, so we need c.
C is there.
0.05 plus 0.3. 0.05x plus 0.3.
For this line, you are able to see, right? This line.
Yeah.
What is the equation of line? Because it starts with 0.3, right?
Yeah.
This is 0.05
0.05x plus 0.3.
Yeah. Okay. Everybody understand this equation of line?
Yes.
Yes,
Yes.
sir.
Okay, this is equation 1. And what is the equation of this line?
Point
0.5x plus
5x plus 0.5.
0.5x plus 0.5.
So that is the equation of second line. Now we wanted to find the probability between 0 to 2. So between 0,
Sir, in second equation, how C is coming 0.5?
because it is started with this, right? The second
Okay.
line. It will start with 0.5, right?
So
So
the
that is
first
your
one is starting. We need to. I think for zero, na?
no. So this is the line, right?
Yeah, yeah.
So this line is starting with
Point 3. C is 3 for this line.
0.3 plus 0.05x, right? And with this line, it is starting with 0.5. So 0.5 plus with this slope 0.5
Yeah.
x.
Sir, in question we need to find 0 to 2.5. I think.
Coming there.
X is
Probability.
greater than or equal to 1.
Now we have to substitute that x now to get the value of y.
Now you have to substitute the x. So which x is you will substitute? 0 and 2 first in the first line, right?
Yeah,
So
and
not
0
0
2 to
actually,
2.5.
2. And then here 2 to 2.5, and you will get the answer. So another way of solving this is we need to find the area of this area under this curve, right? Between 0
Yes.
to 2 and between 2.5. So here you can see you can find the area easily, right? If you make it a square, something like this here, not square, rectangle. So what is the area of this rectangle? Okay, 0.3 into 2, right?
0.6.
0.6. Okay, then if I break this into here, one triangle with one rectangle, but for that you have to find this
It is becoming very
equation of
complicated,
line.
sir.
It will become lengthy.
Okay.
So go to
And then
sleep.
again you have to find out y. Na?
Yes, it's becoming very complicated.
Okay, fine. So okay, we'll drop that idea then. Okay,
This
so
equation of line is
it's easier, no? Okay, fine.
easier,
So
much easier.
okay, and so what then? Now tell me what is the value of x is greater than or equal to 1? How to find probability that x is greater than or equal to 1?
1 minus x is less than equal to
1 minus probability x less than
Less than 1. Yeah.
Okay. So if you try to find it, you'll get the answer easily, right? But can you tell me this value will be included in it or not?
Which?
0.3.
that will be included.
Huh?
That will be included, I think. While
Yeah.
we are putting the value of x in that equation, so it will be getting included automatically. No? It is getting included automatically.
Yes, sir.
It will be included.
Yeah, correct, right? Yeah.
Sir, in case of x is less than equal to -1, so in that case, 0.3, then again we have to calculate for the slope, right?
Huh?
Slope portion.
Yeah. Same. Again, you have to calculate the same slope. Yeah.
Okay.
So please solve this, sir. X less than equal to 1.
It's easier, no? This wait. One minute. Okay. Sorry. So who asked me this question? Find.
Sir,
Okay. You should say your name. So actually, okay, I don't know. Like you guys are there in Python. All of you are not maybe in the Python.
No.
But we will be using this strategy in Python. So those
You
who
are
wants
taking
to
Python also, sir?
yes, only
Nice.
one session. Okay, so the thing is, uh, whoever wants to solve this question or who wants to tell the idea of solving that question also, that also is fine. So that I don't want to solve the questions. they they can actually solve the question. Okay, tell me from where to show. Can you tell me the values again? Here I think it's -4, huh? -4, -2, 0, 2, and 4. Correct? Maybe this is 0 here
The
until
3 is missing in x-axis.
3. Okay, 3 is required, na?
Yeah,
Yeah, here.
the steep one.
Here I think some value it's 0.3. Then what is here? This is slope, right? So this point is slope, and this 3 it's a steep. What are the values here? I think here it's 0.5, right? And here
1.
1, huh?
1. At 3 it's becoming 1. At 3 it is becoming 1.
Okay, at 3 it's 1, right?
Yes.
Not 4, right? And from 3 onwards it's 1. Okay.
Yes.
So what we have to find is probability is that x is
Yes,
x.
then
So 1 should be here, right? Somewhere here. And what we have done before this problem, we have found out the slope of this line. So what is the slope of this line? 0.05. And what was the equation of this line?
0.05x plus 0.3.
Correct? Huh? Okay. So I wanted to find, so basically I wanted to find the area, this area, right?
Yes.
Correct? This area. So what should I put here?
The question is x is greater than 1.
Yeah. Sorry. So I wanted to find this area, right? This area, right? So I wanted to
That
find
is 1 minus.
This is greater than or equal to 1, which is nothing but 1 minus probability that x is less than 1, right? Less than or equal to 1, same thing.
Less than 1.
Okay. So that means from 1 I have to subtract this red color area, right? Okay.
Yes.
So what is the probability? So what is the probability of this area? Can I put 1 here?
0.35, na, sir? If I put 1
0.
over there.
0.01 into 1 is 0.3, right? So it is
0.35.
0.35.
Sorry, 0.35. Sorry.
So and this value, if I put here in this equation, so it will be 1 minus 0.35. So which is, so is it a correct answer?
No, sir.
Integrate the thing.
It's 0.55, sir.
Yeah.
0.55.
So what wrong?
So actually 1 minus 0.45 will become 0.55.
No, sir. For finding area,
0.45.
So for area we have to integrate.
Integrate between?
So within the given limit, minus 2 to 1.
But this is CDF, right? This is not a PDF. So generally, if you wanted to find, so if you are going to integrate, actually you are integrating the PDF, right? Then you will get the CDF. Correct? What is happening here?
So equation of the line is incorrect.
Equation of line is incorrect. How? Correct? No. Yes. Here it's 0.2 and this one was 2.
I think, sir, C is not right. 0.3, maybe. I feel like that.
C is correct. C is also correct.
Mine is coming as
Someone is saying
0.05x plus 0.4 somehow. I'm just checking my notebook.
0.05
0.05x plus 0.4.
0.4 why?
I'm just checking that why it's coming that way.
So in this equation, sorry, in this diagram, if you see, it is starting with 0.3 only, right?
I actually I didn't calculate the slope separately. What I did was y minus 0.03 equal to 0.05 into x minus minus 2, that is x plus 2. So that way I got that.
By intercept form.
Intercept
Find it to
Yeah, because
0.4.
y, if you are taking y minus 0.3 equal to 0.05 into x plus 2 should come now, because that is minus 2 na, x coordinate
Okay.
of that point.
So we have to find difference, and minus 2 it's going to 4. What's the problem? It's going to 0.3.
So I think we can you go to that notebook where you were writing?
Yeah. Tell me.
Here this 0.3 you are taking this y minus 0.3 because of that 0.3 is going that side, right? But at the same time you have to also consider 0.05 into x plus 2 now, because that x coordinate we are not considering in the equation of the line.
Okay, so if you are saying this, okay, we will try to solve by your format, right?
Okay.
So
if I make the equation y minus the y coordinate, that is 0.3. Okay, you can write y minus 0.3.
Y minus
0.3. That is y minus y1. Right, equal to 0.05, that is m, into x minus x1 we are not considering over here now. X minus x minus minus 2 is x plus 2 now. It should be plus 2 because x minus minus 2, so x plus 2, that x coordinate is minus 2 itself now, so you have to make it plus 2 now.
Okay.
Now check it.
No, still I'm not getting it.
Y minus 0.3 equal to 0.05x plus 0.1. So now when it will 0.3 will go there, it will become 0.4.
Okay, you are saying like this, huh?
Yeah.
But is this...
So it will be x plus 0.4. Now the answer will come right because I have solved that way and I am getting 0.55. Because here we were not considering x coordinate, na, so we forgot that, I think. For the same point.
So it's 1.4 you're saying, and if I add this, okay.
If you substitute now x value, you'll get 0.55.
Because it's not started with 0, that's why, right?
Yeah, I mean, if you are considering the 0.3 coordinate, then we have to also consider the x coordinate of the same point, no?
Right.
Sir, can't understand the...
Yes, sir. Yeah, there's a shift now. Here a shift now, sir. So C is 0.4, sir, because here a shift.
C is 0.4. That's true, right?
Yes, sir.
So that is true. So what is happening here? So everybody understood or not? What's happening here?
No, sir. No, sir.
No, sir. Why it's 0.4?
Okay. So there are types of equations, right? How to find the equation of a line?
No, sir. For equations,
but it is a continuation of the previous, right, sir? What you have find out.
So that means that means that previous also is wrong, no? Previous also should be the same thing, right? Same equation you have to do. I don't think if you use that other equation, you get the same answer. See, I haven't solved. Hello?
Sir, can you check your mic?
Audio is not clear.
Yeah, now it is okay.
My voice is clear, right? Audible.
Now it is okay.
Okay. So previous question I did not solve the final answer, right? I just wrote two equations, correct? One equation for this line, right? And one equation for this line. But we did not solve the final answer. So we don't know is it correct or not, right? Have you tried? Someone has tried that question.
Sir, the problem is same. The C is different from all these equations.
Actually, you see so y minus y1. So this is the equation of line, right? M into x minus x1. Correct? Generally, that y equals to mx plus c, when we'll use, when that line goes from the origin, right? Right. So that means y minus y1 was 0 and x1 is 0, then you will get this equation. Correct? Right? Y equals to mx plus c. Here what is happening, here we are not, so what mistake everybody like we have done is, so since it is not starting from the origin, it is starting with 0.03, right? Because y is starting, we are not considered, we haven't considered this points coordinates. So actual equation should be y minus what? 0.3. Slope was correct. Slope was 0.05, right? And x minus into x minus
0.5.
No, minus 2.
Okay.
Right. So this should be the correct equation of line. So this will become, so 0.05x plus 2 into 0.05 is 1. Oh, sorry, 0.1, and this 0.3 will go, it will become
0.4.
4. So this is the correct equation of line.
We need to correct other equation also.
So yeah, the second equation also, it should different. So what should be? Y minus
y1.
So y1 is what?
0.5.
0.5 equal to m is 0.5 into
x minus 2.
2. So that should be the correct equation of line. So it will become y equal to 0.5x.
It's 1.5.
Plus what? How much? It's 0. What 5 minus 0.1. Oh, sorry, minus 1. So it will become plus 0.5. Right? Okay, so what is happening here? Even with that equation, right? Y equal
So
to
it will be 0.
minus 0.5.
Minus 0.5.
Because it will be minus 1 plus
minus
0.5.
Correct. So that should be the equation, right? Now if you put the values here for that previous equation also, then you'll get the correct answer. Right?
Yes, got it. Sir, 4.2 question number 4, sir.
Sir, also 4.5 question number 5.
Yes, sir. I have also problem with that.
Yeah.
4.24.
This is done, right? 4.4 is completed, right?
Yes, 4.4.
Yes, sir, I have a doubt in 4.2.
Can you please help me with the problem 4? Somehow I'm not able to get the correct answer here. It's a CDF that, problem
I have
4.
the same problem.
Here, this is 4.4 question number 4, right?
Yeah, question 4.
Yeah.
3 I am getting, 5 I am getting, 4 I am having a issue.
Okay. Can you give me a moment? I'll just have a water and I'll come back.
Hello? Sure, please. Sure.
Just a minute.
देख यूजुअली क्या होता है, अगर कॉल पे रहूंगा ना और मिस कॉल अगर आया, ठीक है, तो अलर्ट नहीं आता है. मैं स्पेसिफिकली कॉल में जाके चेक करूंगा तो मेरे को दिखाएगा. पता नहीं आईफोन का है वैसा. एनीवेज, हाँ बता ना. वो आई थिंक मम्मी आ रही है ना, कोई कॉल वॉल चल रहा था. एक्चुअली मैं देख नहीं पाया बिकॉज मेरा असाइनमेंट का लास्ट डेट है ना, तो उसमें रह गया मैं. तो अभी भी मेरा चल ही रहा था, हुआ नहीं. ठीक है. और उसने जो विक्टोरियन क्वीन का डाला था वो मैंने देखा था, तो अभी भी पिछवाड़ा उसका बहुत ही ये लग रहा है, बड़ा लग रहा है. उनको क्या लग रहा है?
Someone is talking.
Yeah, and he is completely oblivious to this call, and we are able to hear everything.
Yeah.
Can someone extend 4.2? 4.2. So now question number 4.
Sorry.
Can someone extend 4.2? Question number 4.
We are looking at 4.44.
Yes, I have asked.
Yeah, someone else.
Yes, I have asked.
So in that case, shall I tell you how to solve that?
Yes.
So in
It
this
will
case,
save our time. Yes.
yeah, in this case, you need to plot the cumulative distribution function, which is given in the graph. Okay.
Hello.
Just let me open.
And since it is given y equal to 2x square plus 1, so so you need to put one value is -2, -1, and you need to find the y. It will be coming. One value will be 3, another will be 9. So if you add both these three, it will be 0.6. You will get the cumulative function for the y term.
Okay. This question's answer is done, huh?
No, it was something else. Please, for the fourth one, please.
So shall I start, or you guys were discussing something?
No, that was something else.
No, but have you finished, or?
Oh, he had just started.
No. What I'm saying is, should I interrupt, or you guys wanted to continue?
That was a different problem. Kindly.
Yes, please interrupt, sir. Let us complete.
Okay. So this is the CDF given, right? What you have to find is probability that x is x should be greater than or equal to -3 and less than or equal to 0.5. So how can I find it out? So I can write actually f of okay, shall I'll try to write it. So I wanted to find x is this 0.5. How much? 0.5, yeah?
Yeah.
Okay. So that means, suppose I have my x is started with, let's say, with -3, and it is so I or it is started with some other value. Let's say I wanted to find this area, right?
Correct.
So how can I find? I can actually find. So what is the area less than -3? This area. So this is probability that x is less than or equal to 3, -3, right?
Yep.
Right. And what is probability that x is less than or equal to 0.5? Which one is there?
Total area.
This area.
Yes.
The blue color line, right?
And if you subtract, we get in between.
Right. So if I subtract this area from this entire area, the blue color area, I'll get the answer, right?
Yes.
Yep.
So that means basically I wanted to find this thing, right?
Yes.
Okay. So what is fx of 0.5 now?
7/8.
So where is my 0.5 lying? It's lying between this 0 to 1, right?
Yeah.
And what is the equation of it? 1 minus
1 minus 1 minus x square by 2.
Okay, okay, just
open brackets, please.
Sorry, 1 minute. Maybe I'll write by seeing it. This okay. 1 minus 1 minus x square by 2. So then fx of 0.5, what will, so I need to just replace that 0.5 here, right?
Yeah.
1 minus 0.5 whole square by 2. So this is nothing but 0.5 square by 2. So what is 0.5? 0.5 is nothing but 1 by 2, right?
Yeah.
So it's 1 by 4.
1 by 8 totally.
1 by 8 and
7/8
should be 7 by 8. Okay.
Yeah.
So this is 7 by 8 and minus 3. So where is minus 3? 0. Minus 3 is 0, no?
Yeah.
So I think that answer should be 7 by 8. What is the value of 7 by 8?
0.875.
So this is 0, right? 7 by 8 minus 0, which is nothing but 7 by 8. So 7 by 8 is
0.875.
0.8750, sir. Yes.
Right?
Yes.
Is it correct?
Yes. Can you go back to that question, sir?
Hello.
Yes, sir.
Yeah.
Hello, sir. Are you there?
Hello. Sir. Hello.
Sir, are you there?
Okay, so this is clear. This question is clear. Okay.
Yes, sir.
We don't need to add up any values. We can just take the probability that comes at 0.5 and subtract it from whatever beat on the other side. That's it, right?
That's it. That's it.
I don't need to integrate or anything.
Integration. See, the CDF, right? CDF, it's already the integrated value, correct?
Yeah.
Because you are integrating what? You are integrating the PDF, and then you'll get the CDF.
CDF.
So this is already the integrated value. What is the integration actually? Integration is nothing but all the area, or you can say the cumulative things. So this is addition actually, right?
Yeah.
Addition of everything. It's an integration. That's
Sir,
it.
I have a problem with assignment
4.5 or 2.
Okay, you can discuss. That is also in pipeline, sir. 4.55 and 4.22. These two questions are in pipeline.
Sir, assignment number 4.2.
Okay, 4.2 will take first. 4.2, question number
2.
4, sir.
2 and 4, okay.
Okay, so
sir,
this
I'm
is
not able to get the right answer.
Question number 4, sir, yes.
Provided that x equals to 8, given that x is greater or equal to 4. Okay, I'll see the answer. Is it okay? No.
It's not easy one, but somewhere I'm lacking.
I just want to see. Sometimes I don't solve the equations, right? Okay. This is the CDF of x is okay, but this is a discrete random variable, right?
4 only. 4,
Yeah,
4.
sir, it's easy. 4,
Sir, 4 only, sir.
That's okay, but this is it's a cumulative distribution function of a discrete random variable.
Yes.
So question number 4, what do you have to find? Provided that x equals to 8, given that, so you know what is how to write the conditional probabilities.
Yes, sir.
Okay, tell me. Okay.
So,
just a minute.
8 intersecting with x greater than 4.
Provided that x equals to 8, and given that what? This is
x is greater than 4, sir.
So how can I write x equals to 8 and
intersection x is greater than 4 divided by x is equal to yes, sir.
Correct, right?
Yeah.
So this is the index. This joint density is nothing but the intersection. Okay, right?
Yes, sir. Yeah.
Okay. Now tell me. Okay, this is a discrete random variable, right? So 4, 5, 6. It will take like this values, right?
Correct.
Okay, or 9 or 10 something, whatever. So x equals to 8 is where? Here, right? And x is greater than 4 means what?
All.
Everything here, which is right side of that 4, right? What is the intersection between provided that x equals to 8 and x is greater than equal to 4?
X equals to 8.
8 only.
X is greater than equal to 4.
No, sorry. This is on.
Yeah, this is discrete one, sir. 8 only. 8 only.
Only 8, right?
Only.
Yes.
So this is what? Provided that x equals to 8 divided by
x greater than equal to 4.
Yes.
This is the only probability you have to find. Now you can find, right? What is probability that x equals to 8? X equals to 8 is 1.
0.12, sir.
0.12.
Sorry. Okay, sorry. Okay, this is CDF, right? Oh, sorry.
Yeah.
So it should be
0.12
is x equals to 8. And what is probability that x is greater than equal to 4?
0.2 plus 0.12. 0.32.
So 0.12 divided by 0.32. What is the value? Answer?
0.37, I think.
Can you check? Somebody?
0.375 something it will.
So is it coming correct?
Yeah.
Understand?
Thank you.
So please solve it, sir. So please tell the numbers once again. It's 0.12 is okay, and x greater than
4 means which values you have to take? Tell me. Okay, so how to solve these problems, you know? So you can actually, can you tell me the numbers? I will draw a graph here. CDF. So if you give me, okay, I'll try to draw a graph. So just tell me how to draw a graph here, okay? Who's going to help me here? Yeah. So x is greater than 0. Nothing is less than 0.
In
0.
x is 0, 1, 4, 8.
Yeah. So it's a discrete random variable. So we know that it is going to take the discrete
1,
values.
4.
So between 0 to 1,
it will be 0.29.
So this is straight line.
Yes.
Yes.
Okay. Okay. Between
Then
1
at
to
1 it's open circle. Yeah.
That's
One is excluded.
At 1
Open circle.
Excluded.
but how to draw the CDF now?
Yeah, 0.6. There will be a jump, sir. There will be a jump of
Is jump, sir.
Jump of what? How much?
0.39. 0.39.
So
0.39.
try like this, huh? So
Yes.
what is this
0.68,
value?
sir. 0.68.
0.68. And this tape size is what?
0.39.
Okay,
0.39.
0.39.
Right.
And it will go 1 to 4.
So 1 to 4 it is constant, right?
Yes.
Now at 4
it will be 0.8.
0.2. There will be a jump of 0.2.
Jump will be 0.2.
So here it's 0.88 and this jump is
0.2.
0.2. At 4, right?
And 4.
And from 4 to 8, it's constant. It's 8, huh? And at 8, what's
0.12. Jump will be 0.12 and it will be constant at 1.
Sorry, this what I'll do is I'll just remove this one. So here this value is what?
1 and 0.12.
And this jump is
0.12.
0.12. Now
and it will be
from here
one,
it's a constant 1, right? Now this is my CDF. Now the problem was, this is clear, right? Conditional probability that x equals to 8 divided by probability that x is greater than or equal to 4. So what is the probability that x equals to 8? We can directly find
0.12.
Which one?
0.12. 0.12, sir.
Right. So this basically this, right? This
yes.
Step size.
Yes.
So this 0.12. Probability that x is greater than or equal to 4 means which probability?
0.2 plus 0.12. That will be 0.2, that step 1 and 0.1.
This step and this step.
Yes.
Everyone is okay with this?
But sir, suppose sir, if I want to solve to 1 minus less than equal to x4.
You can solve now.
Yeah. So let us find it out that way also. So 1 minus.
That is, so this is equal to 0.39.
Correct.
Plus this jump. This jump is what?
0.29.
So what is 0.39 plus 0.29?
0.68.
0.68.
Yes.
1 minus 0.68.
Yes,
0.68
is. Yes.
So this is what?
Yes, 0.32, sir. 0.32.
0.32. So now 0.12 divided by 0.32 is how much?
0.375, I think.
So that should be the correct answer, right?
4.55, sir. Next question, sir. 4.5.
Sir, I have a doubt in one question, 4.2.
4.2.
Question number 7, sir.
4.2.
Yes, question number 7.
Okay.
It's given as geometric x equal.
Okay, first of all, tell me what is the range of a geometric variable?
1 to infinity. 1 to infinity.
1 to infinity?
Yes.
Everyone is okay with this?
Yes.
Huh?
Yes,
Hello?
it's 1 to infinity.
1 to infinity, right? So,
Yes, sir. Yes,
so
sir.
and what is the CDF of a geometric random variable?
So P and 1 minus P. 1.
P what 1 minus P to the power K, right? Which one? CDF I'm asking, not the PDF. PDF is 1 minus P to the power K minus 1 into P, right? So this is the CDF, right? You know CDF of a geometric random variable, right?
CDF will be the summation, isn't it?
CDF will be summation.
CDF is what? This
It's
one.
a summation.
Okay, this is actually the CDF, right? This CDF, right?
Yes, sir.
Sir, we geometric function have PMF, na sir?
No, geometric function
No,
has
no,
PMF, but it can have a CDF also. So the PMF is 1 minus P to the power K into P, correct?
Isn't 1 minus p to the power k minus 1?
Yes.
Yeah. So,
because we are not taking 0 as a in the range, right?
huh?
We are not taking 0 in the range, right? So we are
0 is not there, right?
Yeah, so
Because
1 minus
geometry
p to the power k minus 1 into p, where p is the probability of success.
Correct. So that is your PMF, right? Now the CDF is, okay, so this is the function, this is a formula for CDF. I'm not going to derive it. You guys can derive it actually. It's not that difficult. So you can derive it by using that, because since it is a, how can you derive it? First of all, tell me.
Sir, is it possible for you to draw it or like show it us on Desmos or something?
Desmos is not there with me, so maybe I will try to show. Like, I will ask my colleagues to show in some next, session. Right now, I'm not having the Desmos, and I don't know how to use the Desmos also. So I'll ask them like to show on the Desmos. But how to find the CDF of the function from the PMF? You know, right? So if PMF is there, what you are going to do is you are going to add every probability value, right? And it for first success, what will be the probability for
P.
geometric random variable?
P.
P. For second success,
1 minus p into p.
P. For third success,
1 minus p square into p.
to P. Like that, right? So what is this? So it's becoming a some function, right? You know this thing, right?
Geometric
only, yeah. So
geometric progression.
Geometric progression. So how to solve it? You have to find the common factor, correct?
1 minus p is
And 1 upon and that regular formula, you know. So how to do the convergence, and we'll get the CDF of that random variable.
You mean a by 1 minus r summation till infinity?
You know that, right? So if you have that formula and this p plus 1 minus p into p plus 1 minus p square into p. So right, so it will be like this. So what thing you can make common? P, right? 1 plus 1 minus p. Now how to solve this?
A by 1
by taking the infinite
common ratio, right?
A divided by 1 minus r.
So what will be?
A is 1. R is 1 minus p. So it's going to be 1 by p.
It's 1 by p, yeah?
Yeah. So p and p will cancel and CDF will come as 1.
CDF will come as 1, it's okay. But if you wanted to, so it is actually the summation of things, right? So if you wanted to find it in this way, so it should be k will go from 1 to infinity, and you will be having that, but p into 1 minus p to the power k, right?
What I mean to say is maybe we should not sum it till infinity. Maybe we should sum it till k or something.
Yeah, until k. So until k, and you will get that formula. To get the formula.
Shouldn't that be k minus 1?
Different.
Yeah, because if you find till infinity, you'll get 1, right? So,
yeah.
So you have to find in some for some k. It will start with some k, and you can until k for k plus 1 trial. What will be the summation? So just guys, you can see that derivation somewhere on internet also you will find, or some textbooks also you will find. Okay, I don't want to find summation. Sorry, the derivation. So basically the thing is, if you have this geometric random variable, and the range of a geometric variable starts like it's from 1 to infinity, correct? Right?
Yes.
And the CDF of it, from the formula you can from the derivation you will know that 1 minus p to the power k, and this is for k from 1 to infinity, and below 1, if x is taking the value below 1, the value for CDF, that the probability is 0, right? So this is normal CDF function for geometry. So if you wanted to know the derivation, what I can do is maybe I can write it on some paper and post it on the Discord. Okay, I don't want to solve it here. Okay?
Yes, sir.
But I don't think it's very difficult derivation.
No, it's a second option actually.
Second option, yeah. So maybe we can go to question number 5 because I don't think.
4.5, yeah, 4.55.
I have a different question. CDF, is it always equal to 1? I
Yes.
mean, the complete CDF?
Yes.
Can there
For
not
the
be
entire
some-
range, it will be 1. No, that is a property of CDF. So cumulative, all the probabilities, cumulative probabilities, it should sum equals to 1 in the given range of that random variable.
Sir, maybe PDF should be, maybe PDF is greater than 1.
PDF can be greater than 1. That is.
Yeah, sir.
Can be. I'm not saying it will always be. It can be.
It is not compulsory.
So basically, what is the difference between the PDF and CDF? Whether the PDF gives us the shape of the curve, whether that is.
PDF will give the shape of the curve.
Shape of the curve. Right?
Sir, I have a doubt. Sir,
Yeah,
in continuous cumulative function, mixture of both cumulative and continuous, we have in a particular point like x is equal to 1. The probability is always 0.
If it is at that in that sorry, what do you say?
No, sir.
In the discrete and
I want
continuous
to
thing,
know
right?
about in jump. Is there any
mixed
jump?
thing, right? Yeah, mixed.
Is there any jump? Let us assume.
Here.
The jump is x equal to 1. So is there probability 0 or is there a change?
So where there is a jump, right?
Something?
Yeah, where there is a jump, it's not 0 because it's a discrete random variable. We have
it's a change. We
one.
consider change as a probability, no?
Yes, correct.
Okay.
So here in this case, if you see it's 0.7 minus 0.6, how much? 0.07. It's a probability that x equals to 1. Right?
Okay.
So
yes, sir.
if it is a continuous, then we are not able to find the probability at that point. In discrete, we can find.
Yeah.
Okay, in 4.5, which question?
5.
Question number 5. Okay. So this is our normal function, normal thing. Right? Okay. This is PDF now, right? It's PDF.
PDF.
And what PDF? So what is given here between 0 to 1?
First
It's
C
0.1.
to find out.
Yeah, but so you have to find the CDF of it first, right? So how will you do that? Yeah, this is some interesting question.
So area under the curve will be 1 total. So
Yeah,
from
that
that
is
I will find the
You
C
find
first,
C.
C, and then I will find out the probability 1 to less than 2.5.
Okay.
Yeah.
So can you tell me this
minus.
PDF? Just tell me this one. Okay. So this is probability density. So this is for this random variable is a continuous or discrete? That is an important question. Okay, tell me the values first.
It is given as PDF, sir. There is a continuous random variable.
Yeah,
There is a continuous, no? It's a PDF.
Correct. Yeah, that's what I just asked, like.
No. Can PDF be used for mixture also?
Mixture.
Can the term PDF be used for mixture also?
We can't use. Actually, we are not able to find that.
But sir, CDF can be used for both for the discrete and
CDF for for everything, for
CDF
everything mixed also. Okay, tell me the values.
0.1. That is x greater than or equal to 0 to less than 1.
So less than 1.
Less than 1. Greater than or equal to 0, less than 1. And then Cx, x greater than or equal to 1, less than 2. Then 0.3, x greater than or equal to 2, less than 3. And last one is 0 otherwise.
So
less than equal to 2 is less than 2 in second line. So I think it is less than 2 in second line.
Okay. If this is a continuous random variable, right? Then it doesn't matter actually. These things, right?
I'm just saying the sequence.
Yeah, I understand that. What I'm trying to say is it's okay. If I write this also, this is correct only. Okay. So in the exams also, if you find some greater than for continuous, I'm saying for discrete it matters, but for continuous it doesn't matter. So if sometimes if it is like this, right? This is not incorrect. It's correct only, right? So tell me, first of all, you have to find the value of c. So how we will find the value of c? You have to integrate, right?
Yes.
So between 0 to 1,
0.1
fx of x
fx, yes.
dx plus
1 to 2 cx.
So okay, so
Okay.
same formula, right? So I'm
Yes,
just
yes.
okay. I'll write the values here directly. Will that be okay?
Yes.
0.1 dx. Okay,
cx
here
dx.
cx dx plus between 2 to
2
3 is
0.3
dx. That's it, right?
Yeah.
And otherwise 0, it's okay. So if
Yeah.
I don't write for 3 to infinity, that is okay. And I'm not writing from 0 to minus infinity also, or
Right.
minus infinity to 0 also, because it's 0 otherwise. So it's only anyway 0.
We are taking only support.
One.
Okay.
So
Now
we are taking only support, right?
yeah, correct. That is support.
So which one is support? Can you just explain? Because
Support is where these values exist. So between
probability
0
is
to 3,
not
right?
Positive is positive.
The probability is not 0.
Yeah, that's
okay.
it.
Okay, fine.
Right? Okay, now what is the integration of this? 0.1 x from 0 to 1 plus here
cx
square by 2 from 1 to 2 plus 0.3x between 2 to 3. Now, so here it's 0.1 into 1 minus 0, right? Plus c by 2 if I, so 2 square minus 1 square, right?
Yeah, right.
Plus 0.3 into 3 minus 2. Maybe I'll write here also like this way. So everybody is understanding, right? If anyone is having doubt in integration, let me know it here itself. Okay. So here it's 0.1, right? Plus c by 2 into 3 plus 0.3
Sir,
into.
can you scroll a little bit upward? We can't able.
Which one?
Scroll it up, sir. What is saying?
Scroll, sir. Please scroll your page upward.
Oh, okay, fine. So, it's okay.
Yes, sir. It's perfect.
Okay. Now, so and you know that if you integrate everything, this value should be equal to 1, right? This is 0.3 plus 0.1 is 0.4 plus 3 by 2 is 1.5 times c. It should be equal to 1. So this will become 0.6 equal to 1.5 times c. So what is the value of c here?
0.4.
0.4, right? Correct?
Yes.
C is equals to 0.4, right? Now I found out the so my
sir,
simply we can just 1 minus 0.4. Can't say that, is it?
1 minute. Yeah, what you are trying to say is?
I was thinking that it is, since the CDF should be the total value of CDF is 1. The 1 minus 0.3, 0.1 I thought it comes
No. That will be incorrect, right?
Okay. Got it.
Sir, in this integration, even if we are not integrating first and third term, we are getting the same answer, sir. So what would be the logic? Maybe that it is without without
so
variable.
Why we are getting this? If you
Same
directly
answer.
because this step size is 1, right? This interval is 1. If the interval is different,
Yeah, we'll get different answer. Yes,
yeah.
yes,
See, if
yes,
it is
got
4,
it,
right?
got it. Okay, got it.
Then it will be different.
Yes,
Now
sir,
it's it is because coincidentally it happened here.
correct. Yes.
Right. Okay. So my PDF becomes now like this, right? Okay. Now what do I have to find out? I have to find the value of probability that 1 is less than x less than 2.5. So basically what I have to find out here?
2.5 minus 1.
Yeah. So I have to find CDF fx of 2.5 minus fx of 1, correct? So how to find fx of 2.5? So 2.5 lies here, right?
Yes.
Between this interval. So so integration of 0.3 dx between what?
2 to 3.
2 to 2.5, right?
2.5, yes.
And plus the previous things, right? Previous things also I have to include, right? Or not?
Yes, it need to be included.
Because this is CDF, right? So between 2.5, that means I have to go from 0 to 2.5.
Right.
So I have to add previous two terms also. So it will become plus 0.1 dx from 0 to 1 plus 1 to 2
0.4x.
0.4x dx minus what? Fx of 1. Fx of 1 is which one?
0.4x.
So this is actually, yeah, anything. So it's 0.1 actually, right? No.
0.4x.
Fx of 1 is 0.1 only. So 0.4x integration between, tell me, yeah, okay. How can I write integration here?
0.1x dx plus
0 to 1.
0.1 dx.
0.1 dx.
And
0 to 1.
that's it, right?
That's it. That's it.
Right, no?
Why
Yes,
0.4 not to be taken, sir?
Because it is from 1 to 2. So how can you integrate this 0.4x? What is the meaning of fx of minus fx of 1? It's probability that x is less than 1, right?
Less than yes.
Less than equal to also, no?
Okay, less than or equal to 1. Okay, fine. So I can write, I told you, right? This is like this. So you are basically integrating between 0 to 1 only.
But the moment I am putting less than equal to 1, so 0.4 should be included, no?
So this is coming, right? So if you put 1 here, okay, no, not this one. You can't put here 1, right? Because this is not a CDF, it's PDF. So you are saying, but you can't integrate because this equation holds true or between 1 to 2.
Correct.
It's not holding true between 0 to 1, right? Or at 1 is definitely equal to 0.
Yes.
Right.
No, at 1 it is becoming 0.4x, right?
So that means you have to, yeah, you have to integrate from where to where? 0 to 1 only, right?
Yes.
So that's it. So if you see here, so this and this term will get cancelled.
Yes.
So you have remained with this only, these two terms. So if you calculate, it's become 0.3, 2.5 minus 2 plus
0.84 x squared by 2.
0.4 x square by 2. So I can write 2 square minus 1 square, right?
Right.
By 2. I'm writing it directly. Hope you understand. So this is 0.5 into 0.3. How much? 0.15?
0.15, yes.
Plus this is 0.2 into 3. So it's
0.6, sir. 0.6.
So the answer is
0.75.
Is it correct?
Let us check, sir.
Yeah, I also don't know. Yeah, this is between 0.7 to 0.8, so it's middle value, it's 0.75. This is correct. Understand, right, how to solve this one?
Yes.
Sir, can you scroll a little bit, sir? So I think question number
So can
4,
you
sir.
please show that screen where you have
Yeah,
solved
please
it?
show it, sir. Yeah, please show it then.
So should I write it properly or because I have written somewhere here and there?
It is okay, sir.
Okay, sir.
Got it, sir. Got the point, sir.
See, that is the problem of mine actually. I usually write, I don't write. Okay, I'll try to
पेज को थोड़ा ऊपर कीजिएगा
हाँ
थोड़ा और थैंक यू
So first what we did is we found out the value of C. So how to find out the value of C? Because we know that CDF, right? It will if you take the integration over entire range of that x, you will get the fx of x equals to 1. Correct? So by using that property, we have found out. So we have integrated between that support 0 to 1, 1 to 2, 2 to 3, and we have found out the value of C. Then again going back, we wanted to find the value of probability that x is x should be less between 1 to 2.5, what we did is it is nothing but fx of 2.5 minus fx of 1, right? So how to find the fx of 2.5? We have just integrated that PDF between 0 to 2.5, and you have subtracted the CDF. So how to find that CDF? That means probability that x is less than or equal to 1. We have to integrate between 0 to 1. So we did that. We have just subtracted these two values. We are getting the answer.
Getting value of C. After that, I was doing some mistake. 0.4 I was getting. So can you come to question 6, sir?
Yeah.
Can you come to question? No, question 6, sir. Question 6. This is done now.
Okay.
Question 6. Yes. Scroll with yes, sir. This one, sir.
Okay.
So this I got the answer that the first one, open bracket 0, 1 is the right answer. Yeah, I got the answer, but just I want to reconfirm my logic. Why 1 is not included? So can you scroll a little bit upwards, sir? Why 1 is not included? Because it is less than 1, right?
Yes.
Say for example, if it could have been x is less than equal to 1, then I would have been included, right?
It's not like that, right? This is a
no, support is where probability is not 0, right? Where probability is not 0, that is support, correct?
Okay.
Yeah, so this is probability density function.
This is not due to that actually. So you at the initial like the starting of the session, what I told you, what is the property of a continuous random variable?
It's PDF, sir. It is not CDF. It is PDF.
Yeah, that's okay. But what is the property of a continuous like function?
Yeah, continuous function. It has
because
the CDF of the CDF is continuous.
So your CDF is continuous, right?
And non-decreasing, and starting point 0 and ending at 1.
Okay, so this is the PDF, but it's PDF. So what is support? We're integrating between that, right? So the value of probabilities are not 0 in that support, correct? Support of x, correct? So if you integrate this PDF between 0 to 1, that should become equals to so if you integrate between this PDF between 0 to 1, you will get what? CDF,
1,
right?
1,
No,
yes.
yeah, that means you are getting CDF. So what is the property of CDF again? It should be a continuous function,
correct,
right? So that means at the particular value, the LHS and RHS should be equal, right? But in CDF at that point, what is the probability? So probability that x equal to 0 and probability that x equals to 1. What are the values?
0 and 1.
No, 0, 0, right?
No, if I take probability at 0, it will be 0. If I take probability at 1, it will be 0, right? Because
yeah,
the moment I get CDF, moment I get CDF, that in CDF graph, the probability at a particular point will be 0.
Correct. Right. Yes. But anyway, let's suppose this is the PDF given to you, right?
Yes.
Whatever in front of you, and suppose you have found out the value of k. Let's say it's 2. I don't know what is the value, but let's say it's this is PDF with value 2x. Okay. I wanted to find what is the probability of x equals to 1. Okay, I'll try to explain it. Let's say.
Right here only, sir. Yes, sir. Yes.
So my question is, sorry. My question is, if fx of x, right? It's like, let's say instead of kx, I said 2x. Okay.
And x is greater than equal to 0, less than 1. X is greater than equal to 0, less than 1, sir.
Okay, let's say, yeah, okay, fine. Otherwise, huh?
Yes.
Now, I wanted to find that what is the probability that x equals to 1.
That will be 0, no?
But how you said this?
For a continuous function, probability at particular point is always 0. That's what we have learned.
Yeah, that is true. That is true. But okay, I wanted to find probability that x is less than equal to 1.
Okay.
How we can do?
In this case,
you have to find a CDF only, right?
Correct. Yes.
That my point saying this thing is.
Yeah, I'm getting you. I will have to find out my CDF. Yes.
CDF only.
Yes.
So that means you are actually, even though you are given the PDF, you are to find the probabilities, you are going for a CDF only, right?
Okay, so let us integrate it. So it will be 2 into 1 by 2x square.
Yeah, 2x square by 2, something like that. So
yes,
whatever value is coming, I don't know. So that is okay. That's I agreed. But the moment I'm saying provided that x equals to 1, how you are saying that 0? Because that is a property of a CDF, correct?
Yes, yes.
In that continuous function, you can't find
probability at a particular point.
That is a property of a continuous function.
Yes, yes.
Right.
Yes.
So we are like concluding this because we are going for the CDF, that is which is a continuous function, and we are saying that for a continuous function this is not possible. What does that mean is at that point you are not having any value, so you are actually excluding that point, right? So what you are saying that reaching to this one, so at 0.99, 0.9999 something, you are getting the values, but once you reach at 1, it's 0. Correct, right?
Correct, got it. That is the reason why both 0
that
and
is
1
why
are
this 0 and 1 are excluded.
But at both location probability is 0, right? And
yes.
Support is all point without probability 0.
So in that support, that 0 and 1, everywhere you'll go, you'll get the value. But when the moment you come to that 0 and 1, you get 0.
Correct.
That's why these brackets are there, right? Okay. Anything else here? Nothing. That's it, right? I think we have covered almost all the all the concepts. Right? Same thing we are going to use again to solve any question. So if you understand all this point, right, I don't think there is a problem in solving any question. Correct? What I assume is okay. Yes.
Hello?
Yes, I'm able to.
Can you ask a conceptual question, sir? While explaining in a next week number 4.6, so lecture number 4.6, where we are talking about different types of distribution. So in case of CDF of normal distribution, professor has used a phrase, no closed form expression. There is no closed form expression for CDF of normal distribution. So what does it mean? What is the meaning of no closed form expression?
Where it is? Where it is?
In lecture 4.6.
Okay, lecture 4.6. Yeah.
While talking about normal distribution, CDF of normal distribution. Hello, sir, are you there?